today to our professor, Dr. Zurazma Muhammad Hassan, who's our mentor for the IDP project. And today we're going to discuss about the title given, which is a driving machine, which includes about the seafood, agriculture, and handcraft products. So I and my teammates going to explain about the IDP project title given. So the chapter 6, embodiment design. To be further elaborate, it is about the product sub-assembly, which outlines gadget component sub-assemblies or physical components is one of the strategies for dispatching the product and having more access to the important data of each portion. Through this physical decomposition, component data can be picked up unaccurately. So what is schematic diagram? A schematic diagram is a representation of the elements of a system using abstract graphic symbols rather than realistic pictures. The schematic diagrams also represent the workflow for the project at hand, which engineer and the viewer to better understand the working concepts of the overall solution. The figure in the next slide shows the schematic diagram of fish cracker drying system. So this is the schematic diagram of fish cracker drying system, which it consists of temperature signal module, fish cracker loading module, humidity signal module, heating module, fan speed module, temperature humidity sensor module, and as well as control module. So what is material selection? Material selection is the act of choosing the material best suited to achieve the requirement of a given application. Many different factors go into determining the selection requirements, such as mechanical properties, chemical properties, physical properties, electric properties, and cost. Materials are selected based on the basic general criteria, which is the performance of properties, processing, manufacturing characteristics, and environmental impact. About the table 6.1, it shows about the type of materials for the body structure. So about the material chosen is about the aluminium, magnesium alloy, steel alloy, and plywood. And about the mechanical properties, it is stated about the density, modulus of elasticity, modulus of rigidity, strength, and portion ratio. So the table 6.2 shows the material properties for body structure. The same thing, the aluminium, magnesium alloy, steel alloy, plywood, and what the properties of the each material. So about the material selection for heating coil, there are two types of heating element, which are the spiral coil heater and tubular heater. The maximum overall heat transfer coefficient for the spiral coil heater is a bit higher compared to the tubular heater. This shows that the spiral coil heater has a better heat exchanger compared to the tubular heater. The tubular heater is more suitable to be used for our fish cracker drying system, as we can save more space. The next slide. The result of parametric design. The attributes of components found in configuration design are parametric designs. First, the power generation is about 69.12 mJ, and the material strength is 0.0868 Newton, and heating coil is 62.83 millimeter, and air changes per hour is 9 times 10 power negative 4 meter cube per second. The ergonomics in design. The ergonomics implies the translation of human encounters and other components of a framework. Ergonomics help within the arranging, planning, and evaluation of industry arrangement and portion and mechanize. The primary ergonomic plan we carry out for a drying fish cracker machine by making four rollers at the bottom to make this machine can effectively move with stacking or without stacking within the machine. Other than that, based on our ergonomic design, we specify the size, sort, and frame of the items for the requirements of the consumer.
My name is Tang Guan Yu, and I am from RK08 Mechanical Engineering student. My part for this IDP report is Chapter 7, Prototyping. In this chapter, I will be talking about the special feature of this prototyping. This special feature for this drying machine prototype was user is able to control desired temperature while the motor speed was controlled by the temperature. Hence, this special feature matching with the SDG Goal 9, which is Industry, Innovation and Infrastructure Goals. In addition, this drying also has a special feature, that is, user able to monitor drying machine data using smartphones. This can be related to IR 4.0, which is Industry Revolution 4.0. Smart factory requirement is being fulfilled. Next, we look about the prototyping of versus the final design. In this picture, we can see the shape of the prototyping and the final design is almost the same, for exception for the conducting part. Due to limited cost, we decided to change the conducting tube ducting to the ducting tube, which is using the PVC. The rest are using almost the same design with the final design. Next, we will look at the schematic drawing. The electric component used in prototyping, which is Arduino Uno, which is an open source microcontroller board that can read input and output. Another one board is VMOS D1, which is an Arduino based, which added Wi-Fi development board. The next one is the L298N motor driver, which is a dual H bridge motor driver which allows speed and direction control of two DC motor at the same direction. But in this prototyping, we only using one motor for the motor driver. Next is a temperature and humidity sensor. This sensor is playing a most important role in our prototyping, which is the control the motor speed using the temperature. So the function is to detect temperature and humidity while the drying in process. Next one is LCD I2C, which is a liquid crystal display to display the temperature and humidity inside the oven. Next, we will look at the schematic drawing of the prototyping. From the left hand side, we can see that the Uno board, which connected to Arduino to DHT11 sensor connected to pin 7, while the motor driver be connected to Arduino Uno pin 12 and 13, and the most important pin 9, which is the enable pin, which is using the PWM function. The rest LCD is connected to pin A4 and A5, and we look at the right hand side, we can see the only one sensor and one development board, Wi-Fi development board, which is connected to pin D5. Next, economic analysis on product. From the bill of material, we can know the raw cost of a prototype was 317 and 03 cents, but the selling price of a prototype was almost at 100 ringgit, and after calculated, we can earn almost 60.37% of profit margin, which is equivalent to Rm 482 ringgit and 97 cents. This is a bill of material. We can see the price per unit cost, which for the each of the material used in the prototyping, and the total cost, subtotal, and the total cost is 317 and 03 cents. That's all for my presentation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Lokman BSman. Today I will proceed with technical drawing. A technical drawing is an engineering drawing. It's a type of technical drawing used to describe a product or component specification. The purpose of an engineering drawing is usually to clearly and accurately capture all geometry feature for a product or part, so that the necessary item can be created by a manufacturer engineer. It may also explain the process of creating the object, may be used during the design process to demonstrate engineering ideas and provide a record of an existing item. All the technical drawing with the dimension will be represented in this section. The dimensions are represented in millimeters. The drawing are all done by using a SolidWorks software. Next is design for assembly, which is we call DFA. It's a method of creating items that are good to assemble. When a product has a fewer pieces, it takes less time to put together, which lower assembly costs. Additionally, if the component include characteristics that make them easier to grab, move, orient, and insert, assembly time and cost are decreased. The decrease in the number of pieces in the assembly has the additional benefit of lowering the overall cost of the part. This is generally where the assembly designs main cost saving manifest themselves. The phase chip drying machine incorporates all of the necessary parameters for optimizing the drying process of fish chip during the rainy season. A portion for the drying chamber is designed to be readily constructed and dismantled. This also allows the drying chamber to open and close without compromising its design, look, or functionality. It also contains a tray holder to make the machine installation procedure easier. Arduino Uno temperature indicator with LED display, humidity and temperature sensor are the electronic and mechanical components required for this drying system. They may easily join and assemble in the rooms, but they must guarantee that they are recovered appropriately in the fish chip circumstance. They can also be replaced by disassembling room to adjust or replace damaged component. Next, we continue with design for environment. Design for environment is a way of incorporating an environmental component into product and service before they are put into production. DFE goals is to develop new product that fulfill cost and performance goal while also reducing the entire human health and environmental repercussion of a product, process or service, taking into account effect throughout life cycle. Because environmental health can be safeguarded against mining threats and devastations, environmental design should be an intrinsic element of platform design requirement. The drying technology of this product utilizes electric energy to ensure that the drying process can be accomplished. Because of the temperature shift, more than half of an input energy is converted to waste heat throughout the drying process. Waste heat capture allows it to be redirected to a function to waste heat throughout the drying process. Waste heat capture allows it to be redirected to a function that would otherwise need grid electricity, reducing the amount of power consumed to mitigate the waste heat impacts. Furthermore, waste heat energy may be employed to improve the efficiency of drying process. When this type of energy is available, the drying machine will be more ecologically friendly. It can also help the environmental reducing the amount of power used. Aside from that, stainless steel is used in various parts of this device because stainless steel can be separated systematically and so join the recycling system. A product made of stainless steel, such as stainless steel wire or stainless steel bands, will never become obsolete at the end of its life. Eventually, the stainless steel sector has shown to be quite beneficial. This is because it conserves primary energy by using it sparingly.
Assalamualaikum. My name is Azim Berusli. My metric number is 181113012. So I will be explaining more on the prototype analysis. First one, why we conduct the analysis. It is to identify the qualities and structure of a system, device, or investigate the problem before starting to fabricate the prototype. Next, it's divide an engineering design into operation or failure mechanism. So, what software I use to test the product design? The first one, I designed the 3D CAD of the prototype using the SolidWorks. And next, I use the NC software to do the analysis. So next is the analysis of the rack structure. First, before I start the analysis, I do the mesh setup, which is the global mesh setup with the mesh refinement of the 1 meter. And next, I'll do the bond missile stress of the rack. So the result shows that a higher level of equivalent stress is observed to occur at the middle of the left and right of the rack structure. The stress region is shown in the blue color contour. At this location, the structure needs to support the distributed load from the trace, hence the overall load from the trace is transferred to the side of the frame. So after I do the equivalent stress, so I do the total deformation of the racks. In terms of the structure deformation, the green color region in the picture indicates that a higher degree of deformation occurs on the frame in the y direction. At this location, the structure also needs to withstand the total load from the trace. It is found that the maximum von Mises stress occurring on the frame structure is a 41,661 Pascal, while the maximum deformation occurring on the structure is a 0.00164449 mm. in the y direction. After I've done with the total deformation and the von Mises analysis, next I'll do the analysis of temperature and the total heat flux. From the result gained from the NC steady state thermal, the highest temperature is set is 25 degrees Celsius, which can be seen only on the front middle part. The heat flux is seen all over the surface of the rack with the highest value of 33.4011 watt per meter square. This concludes that the highest temperature is in the middle as seen in the right picture, then the heat is transferred through the overall surface as the left picture. After I've done with the analysis of the rack structure, then I move on to the analysis of fan blade. So this is the analysis of airflow. We decided to use an external inflow fan as the circulation inlet for our project. This is the drying process. An external intake fan is employed to allow air from the surrounding area to flow into the drying system. Because this intake fan is a tube axial, we decided to utilize it. The tube axial fan features a wheel within a cylinder housing, and the blade and housing are close together. It is an excellent design since it increases the air efficiency. So for the inlet airflow, we set it to a velocity of 1 meter per second as shown in the picture below. So the highest value of the airflow we get is the 0.5 meter per second. So which is a very good value for a closed system of the drying machine. So next is the proof of concept prototype. Proof of concept prototype is activities that is used to validate design concept or assumption. Main goal is to exhibit functionality to establish that a given idea or notion can be implemented. From the proof of concept prototype, then we move on to the design for manufacture. The process of designing parts, components, and products are ease of manufacture with the end objective of producing a better product at a cheaper cost is known as a design for manufacturing or DFM. DFM should be performed at the onset of the design process before the tool is used. The process, design, material, environment, and compliance or tests are the five principles of the design for manufacturing. Based on this, we generated a 5 product design for a good manufacturing process and only picked the best design based on the specific characteristic of its manufacture.
Assalamu alaikum warahmatullahi wabarakatuh and salam sajahatra. My name is Muhammad Saleh from Group 15 and I will be presenting for you today Chapter 8, Discussion and Conclusion. Now to start off this presentation, I will be explaining the general idea behind this project or the objective of this prototype, which is to dry the fish cracker in a short period of time, and it can be used during rainy seasons such as the monsoon season compared to the traditional method. Now, the major issue that is faced by the small and medium-sized enterprises or SME industries in the drying of fish crackers during the monsoon seasons is moldy. And moldy needs 4 conditions to grow, which are water, food, appropriate air quality, and temperature. And moldy in the cracker can be controlled with this concept as we can manage the air humidity inside the prototype. Now, in conclusion, we drew 5 concepts. We sketched 5 concepts, and from the weighted decision matrix, concept 5 was selected, which is the box type design. And this machine consists of a heating element, tray, inlet fan, and a control system. And the frame structure for the tray is considered as the critical point for holding the weight of the fish chips. And after designing, a CFD analysis and a static structural analysis was conducted on this design. Now, the analysis was carried out using ANSYS software, and the main material that was used in the part is stainless steel, which has allowable stress of 110 megapascal. And based on this analysis, the part is considered strong because the von Mises stress is below the allowable stress of the stainless steel, and the total deformation recorded for the frame structure is minimal. And after this analysis, a fluid stream examination is conducted using SolidWorks software, to watch the airflow and temperature inside the drying chamber. And based on the analysis results, all the air is flowing through all the tray, and it can be concluded that the fan position is at its best. Now, finally, recommendation. We have two parts for the recommendations. The first one is for mobile application portion, and the second one is for fish cracker drying machine portion. And the first one is for the mobile application. We could recommend tracking and recording work to follow and track past information, and also remote work such as control on and off through portable phone, and even drying temperature control is recommended. And we also would recommend emergency caution message function, which can be added to guarantee the security of workers and the security of even the production line. And for the fish cracker drying machine portion, we would recommend deciding the quality of the fish cracker before and after the angle cracker is dried by the machine. And we also recommend changing the position of the fan to the heating component so that the hot air can be disseminated more successfully. And also a few considerations are to be taken to keep the gap between the fish at the plate before drying it to permit compelling airstream through all the fishes. So that was it for our presentations. I hope it was clear and helpful, and thank you for your time.